In this tutorial, we're going to do some more complicated procedure statements. The reason that these are going to be more complicated is because we're going to work with different type of data. In the tutorials up till now, we've been working with 450 firms. Each firm had just one observation, all of the various accounts from its financial statements. In this tutorial, we're going to be working with a much larger data set. There's going to be about 1.7 million observations. And in this data set, basically each firm has 250 observations. In other words, it's firm day stock data. Okay, so what I'm going to do here is I'm going to import this data. I'll show you here. This data set is called Final Stock Data 2018. I've saved it as a SAS data set. Okay, it's located in this directory. So what I've done here is I've created a library, a new SAS library called Ben, my first name, and I've pointed SAS to this directory. So anytime I reference the library name Ben, I can point to this SAS directory, which is very useful. If I had multiple SAS data sets, I just specify my library name and I can just reach into that library or reach into this directory that's located on my desktop, my laptop here, and I can pull those SAS data sets in really quickly. So that might be useful for those of you who work with a lot of different data sets. So what I want to do here is I want to create a new SAS data set. I'll call it data 1. And I'm going to set Ben dot, so that's specifying the library name, final underscore stock data 2018. I'm going to print 20 observations of the 1.7 million observations just to make sure that it all was read in here. I'm going to highlight those lines of code. I'm going to click Run. It's going to take a second. And there's the data. If I look here, it says that it was successfully created. There's 1.68 million observations. Let me just briefly explain what this data looks like. PermNo is the permanent number. This is an identifier from the data source. FYI, the data source here is CRISP data, CRSP. Okay, let me show you what that looks like. So CRISP, CRSP stands for the Center for Research on Security Prices. This is a data source. Our university subscribes to this data set, and it basically gives us daily stock data. Okay, so for instance, here in the second column, 2018, January 2nd, so this is the first trading day of 2018. This particular company, ticker symbol JJSF, it's a snack foods company. These are this is the lowest bid price that's reported. This is the highest ask price that's reported. This is the closing price. Okay, on that day, that first trading day of January 2nd, 2018. This is the amount of trading volume. This is the stock return for that day. So notice, so apparently the snack foods company didn't have a great day. It was down 1.75% that day. The closing bid price, the closing ask price, and this number here is the shares outstanding in thousands. So there's about 18.7 million shares outstanding for this particular company on this particular day. This is the opening price, the morning that it opened, January 2nd, 2018. And then here's a couple of different market returns. This is the S&P 500 return for that day. And this is the value weighted market return, which basically is the return, the average return for the universe of stocks in this CRISP data set weighted by market capitalization. Okay, and these are variables that I was able to pull in from CRISP. All right, so here's a whole bunch of data. I've got 1.7 million observations, and it's kind of overwhelming to think that I've got to analyze this much data. So what I want to do is I want to create a few variables that might be useful to us here. I'm going to do this in a particular data step. So I'm going to say data 2, set data 1. So I'm pulling in the original SAS data set, which I called data 1, and I'm going to create a new SAS data set called data 2, and I'm going to create a few variables here that I think are important. So inside this data step, I'm going to create these new variables. I'll try to explain these fairly carefully. The first thing, and by the way, this tutorial is going to be heavy on statistics and heavy on finance. So hopefully you're familiar enough with some of the things that I'm going to be talking about. Let's first calculate the Bidask spread. The Bidask spread basically is a measure of liquidity. It tells us the difference between the ask price and the bid price. Okay, and so I'm going to calculate the spread in the following way. I'm going to take the ask price minus the bid price divided by what we call the spread midpoint, which is the middle between the ask price and the bid price. So I'm going to take the ask plus the bid divided by 2. So if you're looking at that formula there, that's basically giving me the difference between the ask price and the bid price relative to the spread midpoint. You can think of that in percentage terms as a measure of liquidity. Another measure of liquidity, and I don't want to confuse you with the asset turnover ratios that we calculated in previous tutorials, but I can also calculate something called share turnover. Share turnover is volume relative to shares outstanding. Notice that shares outstanding are in thousands, so I got to multiply that by 1,000. Okay, so this measure of turnover is called share turnover. It's different than asset turnover that we talked about in previous tutorials. This measure is telling us how frequently the shares outstanding are turned over every day. Okay, let's see. I could create market cap. So this is the market capitalization. I know the market capitalization is equal to price times shares outstanding. I got to put that in thousands as well because shares outstanding is in thousands. So multiply that by 1,000. Gives me market cap. What else could I do? I could calculate, this is a measure of volatility, of daily volatility. It's basically the range between the highest price and the lowest price in that day. Now I'm going to do something here. I think this is probably going to be useful just to allow you to understand about writing if-then statements in data statements in SAS. Okay, so what I want to do is I want to calculate the difference between the highest price during the day and the lowest price during the day. Now there's something tricky here that you need to understand is, I don't know if I'm going to be able to find it in these first 20 observations, but it's possible that the closing price is going to be higher than the highest ask price. And the reason that is because the closing price might have occurred because there was just a final trade that executed at a higher price than the highest ask price. So I have to write a bunch of if-then statements to make sure that I'm gathering the highest price possible. Now watch what I'm going to do here. I'm going to say if price, the closing price, is greater than the highest ask price, then ask price is going to be equal to the closing price. So in other words, this ask high is going to be equal to the highest price possible, else ask high is just equal to ask high. Okay, so hopefully you understand what I've done here with this if-then statement. I'm saying that if any time the closing price is higher than the ask price, then just make the ask price, the highest price that I want, equal to the closing price. Other words, just make the ask price the highest ask price during the day. Does that make sense? I'm also going to do this on the bid price. So if price is less than the bid low, so if at any time the closing price is lower than the lowest bid price, then bid low is equal to PRC, the closing price, else bid low equals bid low. So these two if-then statements basically make sure that the closing price is neither higher than the ask high price or lower than the lowest bid low price. Does that make sense? And now I can create a measure of volatility. The way that I do this is going to be useful. I'm going to create a measure of range volatility, and I'm going to refer to an academic article published in the Journal of Finance in the early 2000s, which basically said that the natural log of the highest price during the day minus the natural log of the lowest price during the day gives me a very good measure of what we call stochastic or random volatility. Okay, so again, SAS recognizes inside of a data step that I can just say log and in parentheses say ask high. So that gives me the natural log of the highest price minus the natural log of the lowest price. So notice I have to calculate range volatility after I've executed these two if-then statements to ensure that I have the highest price and the lowest price possible. Okay, and that gives me a measure of volatility, a measure of stochastic volatility or random volatility per this research paper that was published in the Journal of Finance. So here's four new variables that I'm going to create inside of this data step. Again, this is pretty powerful here. I'm going to create all of these. I'm going to create all of these variables for 1.7 million observations. When I run this thing, it took computing time 0.03 seconds to calculate all of those new variables. If you tried to do this in Excel, you'd run out of life, I think. So anyway, SAS is very powerful at manipulating very large data sets. Hopefully that was understood in that last procedure that calculated all of these statistics, all of these new variables for 1.7 million observations. So now that I have that, watch what I want to do. So maybe I want to calculate various measures for each stock during the year. Does that make sense? So the purpose of this tutorial is to calculate or do more complex procedure statements. So what I might want, I have a single observation for each stock on each day. Maybe I want the average variable. I want the average of these variables for each stock across these days. Does that make sense? So this is going to be a very useful tutorial in helping you understand how to get the data to be workable. In order to do this, what I have to do is I have to sort by the variables that I'm going to run the procedures on. Okay, I know that doesn't make sense, but when I write this code, it will begin to. So I'm going to say proc sort data equals data2 by ticker date. Okay. So I'm going to sort this data by ticker date. Actually, once I sort this, let me show you what it looks like, just so you understand what it means to sort the data. It sounds silly that we have to pause to look at what what it looks like, but notice that the first ticker, it's going to sort it alphabetically. So the first ticker is ticker A on January 2nd, 2018. And so each ticker, it's in alphabetical order, and I have that same ticker for each date. And then once I go to ticker AA, I have that ticker AA for each date. Do you understand how the data is formatted all the way to the last stock, which is, I don't know, Zoomies, maybe the retail company Zoomies has a ticker symbol ZUMZ, I think. So understand that it's alphabetical by ticker and numeric by date. Okay. So now once the data is sorted by ticker date, I can calculate a whole bunch of things. Watch what I can do. I can say proc means data2. And what I'm going to say here is I'm going to say no print. I don't want SAS to print the output for 1.7 million observations. This is going to destroy my computer. It's going to take it forever. So what I'm going to say is I'm going to say proc means data equals data2. Don't print any output. And I'm going to calculate the average price. Let's make this interesting. Let's calculate the average bid-ask spread, the average daily turnover, and the average market cap, the average price, the average trading volume, the average range volatility measure that we just calculated, and I'm going to do that by ticker, by date. Okay? But what I want to do is I want to output these statistics that are now going to be, I'm sorry, I don't want to do that by ticker, by date. I want to just do that by ticker. Okay? So I have by ticker, by date, but what I want to do that is just by ticker. I want to get the mean bid-ask spread or the mean turnover or the mean market cap by ticker across days. Okay? So I'm going to output a SAS data set. So I say output out equals data3, and I'm going to calculate the mean spread, the mean turnover, the mean market cap, the mean price, the mean trading volume, and the mean range volatility. Okay? And now I'm going to proc print data3 All right. I've already sorted that data. So think of what SAS is going to do here. It's now going to take the mean price for each stock across the days, and I'm going to put that into a new data set called data 3. So instead of having 1.7 million, I'm going to have how many ever stocks there are. I'm going to have one observation for each stock. Run that there. And there you have it. So here's ticker A. Here's the mean bid-ask spread, the mean turnover, the mean market cap, the mean price, the mean trading volume, and the mean range volatility. Hopefully this makes sense. Notice that that first ticker symbol, A, traded 249 times. Okay. Here's Apple. Look, ticker symbol AAPL. There's Apple. Bid-ask spread, turnover, market cap, price, volume, and range volatility. Okay. So this might be useful. Now what I'm going to do is I'm going to do some more statistics here that's going to be a little bit messy. I hope this makes sense. All right. So what I want to do here is I want to calculate the standard deviation of daily returns across the year. This will give me another measure of volatility. I hope this makes sense. So watch what I'm going to do. The data is already sorted. Data 2 is already sorted by ticker. So what I want to do is I want to run another proc means procedure. Data equals data 2. I don't want to print this thing. There's 1.7 million observations. That's going to get messy. Okay. I want to calculate return by ticker. So this is the daily stock return, and what I want to do is I want to calculate the standard deviation by ticker across all of the trading days in 2019. I'm going to output a new data set called data 4. Don't name that data 3 because you'll overwrite the previous data set data 3. And instead of calculating the mean, like I did in the previous proc means procedure, I'm going to calculate the standard deviation of daily returns. Let me print that. So this is calculating the standard deviation of daily returns for each stock across each trading day. So there I have daily return, that says return, but that's not return, that's the standard deviation of returns. In fact, watch what I'm going to do here. I'm going to create a new data step, data 4, set data 4, and I'm going to rename RET to equal volatility. While I'm here, I'm going to drop these other variables that I don't need. This is important because I don't want to be confused about the data that I just created. So SAS calculated the standard deviation of daily returns, but it named it RET. And I don't want that to be confused with the actual stock return. I need to make sure that I rename that variable, and the way that I rename that variable is in this data step. Let me run that. So that gives me volatility. Okay, so now I have average bid-ask spreads in this data set, data 3. I have average bid-ask spreads, average turnover, average market cap, average closing prices, average trading volume, and average range volatility. And then in SAS data set data 4, I have this other measure of volatility, which is the standard deviation of daily returns. I hope this is making sense. Again, this isn't a statistics tutorial or a finance tutorial, but for those of you that are taking classes from me, you'll understand this hopefully. Okay. So now what I want to talk about is how to merge this data. Now, merging data sets is it's a little bit risky. You have to be very careful. Okay. So let me go back and show you. This is data set data 4. The only two variables I have in data 4 are the ticker symbol and this measure of standard deviation of daily returns or volatility. And this is data set data 3, which I have my average spread, average turnover, average market cap, average price, average volume, and range volatility. Okay, so what I want to do here is I want to finish this tutorial, and then in the following tutorial I want to pick up where we left off, and I want to show you how to merge these two data sets together. Okay, so I'm gonna stop this tutorial right now, but tune into the next tutorial, and here I'll show you how to merge data set 3 and data set 4 together by ticker symbol, so that now I have all of the data put together.